So units are particularly important in physics. They allow us to quantify our observations so that other people can use them. So the whole purpose of physics is really to describe the physical world, and units are the way that we do that. Units are physical. They make our numbers actually mean something. Without units, your answers are meaningless. And we can learn a lot about units and how we use them. And we can actually solve a lot of problems based on units alone using a procedure called dimensional analysis. So this is where you look at the dimensions that are in your problem, the units that you have, and you figure out if they make sense. Okay? And a lot of times, these are the kinds of questions involving dimensional analysis that you might find on something like an MCAT exam, because they're pretty straightforward to do. Now we have an international system of standards that we use called the SI system, the System International. And the SI system has some standardized units for measuring different kinds of quantities. For length, our SI unit is going to be the meter. For mass, the SI unit is going to be the kilogram. For time, the SI unit is going to be the seconds. For electrical current, the SI unit is going to be the ampere. For temperature, the SI unit is going to be the Kelvin. And that is just plain Kelvin. There is no such thing as a degree Kelvin. The amount of substance that you have, the amount of something, this you usually cover in chemistry. This would be a mole. And then finally, the luminosity, or the intensity of brightness that you have of something, is going to typically be measured in the SI system in something called candelas. Okay. And what we do with this SI system is we use these units, and we can convert between them with conversion factors, and we can tweak them. Okay. So we can adjust the sensitivity of these units, tweak them, how big or small they are, by adding prefixes. And these prefixes are the metric prefixes that we should know about from lots of other classes. So you have things like micro, which are denoted by that Greek letter mu, and that represents something called 10 to the negative 6. So that's really, really small stuff. Then we have milli is a common prefix that we see. Milli with a little m, that would be 10 to the minus 3. We might have something like centi, like a centimeter. So that's centim, denoted with a C. That would be 10 to the minus 2. And then we have maybe something like kilo. Kilo would be slightly larger objects. That would be something with a K out in front. And that would be like 10 to the third. And we can already see an example of the kilo in the SI system. This kilogram is the standard unit. Okay? And what we want to do is we want to really practice and get really good at knowing this kind of scientific notation to write numbers. Okay, and we want to get really, really good at converting between these different units using this scientific notation format. So let's do some processes called factor label to figure out some kinds of conversions. So this is a procedure called dimensional analysis that we should get very, very good at. So let me ask the question, how many meters are there in 1 kilometer? Okay, so if I want to get this question, if I want to do this conversion, I can use these prefixes and I can do this. So if I have 1 kilometer, so 1 km, and I want to convert that into meters. So I can multiply this by a number, and as long as this number I'm multiplying by is equivalent to 1, I'm not changing it at all. So what I want to do is I want to get rid of kilometers, so I'm going to put kilometers on the bottom of this fraction. And I want to get it into meters, so I'm going to put meters up top. So if I look at just the units right now, without thinking about numbers, I can see the kilometers up top will cancel with the kilometers down bottom, and I'm going to end up with units of meters. So now the only thing I need to do is I need to figure out what's the conversion factor between meters and kilometers. Well, from the prefix chart, I know there's 10 to the third. So 1 times 10 to the third meters or 1,000 meters in 1 kilometer. And what you want to do here is you want to use your calculator. Okay, so when you're running through these lectures, when you're running through this material, get out your calculator. Don't be lazy. Just type it into your calculator. Make sure you can do this. It's kind of straightforward, kind of basic stuff. You want to make sure that you can get this kind of down pat, because this stuff is going to be important. So we can multiply this, do this multiplication. I get 1 times 10 to the 3rd meters out of this, or 1,000 meters. And we probably already knew that there were 1,000 meters in 1 kilometer. So let's do another example. Let's do another kind of straightforward one. How many milligrams are there in 100 micrograms? So I need to do this conversion again. I can do this factor label. So I have 100 micrograms. Okay, and if I want to get this into milligrams, I would kind of need to know the conversion between micro and milli, and maybe I don't know that. So maybe I'll do an in-between step. I'll get rid of the micrograms, and I'll convert those into just plain grams, because I know there's 1 times 10 to the negative 6 grams in 1 microgram. I can read that right off of my prefix chart. And then I can convert this grams, because I want to get rid of grams, and I want to get this into milligrams. So I need to convert my milligrams into grams, and I know there are 1 times 10 to the negative 3 milligrams in 1 gram. I can do my factor label and look at my units, do algebra on these units. I have micrograms up top and micrograms on the bottom that cancel out. I have grams up top and grams on the bottom that cancel out, and I end up with my final units of milligrams, which is exactly what I want. And when I type this into my calculator, you should get 1 times 10 to the negative 7 milligrams. So there is my final answer. Okay. And then the last one that we'll do, last little quick sample, is I'll ask, how many seconds are there in 100 centimeters? Okay. So this is where dimensional analysis really comes into play, and I think about seconds. Seconds are a way that I measure time. Centimeters are a way that I measure a length. And I know that a length and a time cannot be equal. So these are not physical. This is not a physical conversion. I cannot do this. So these are things we always have to keep in the back of our minds. Is something physically possible? Is a conversion physically sensible? Sometimes it might not be, so you just can't do it.